Good morning. I am Dr. Ramya Swetha, Assistant Professor from Civil Engineering Department. Today our topic is methods of dimensional analysis. What are the methods we are using for dimensional analysis? So these are some of the web references which may help for enhanced learning of these particular topics. So coming to the methods of dimensional analysis, in this dimensional analysis we have two different methods. So in this dimensional analysis, based on the dimensional homogeneity only, we are going to understand these methods. Dimensional homogeneity. So coming to the dimensional homogeneity, so the left hand side dimensions is equal to the right hand side. So the left hand side is equal to right hand side, the right hand are equal. So based on that, we are understanding these methods for dimensional analysis. The first one is Rayleigh's method. Coming to this method, it is functional relationship between the variables is expressed in the form of an exponential relation which must be dimensionally homogeneous. So these functional relationship between variables is expressed in the form of an exponential relation which must be dimensionally homogeneous. In this, we may consider y is the function. Y is a function of independent variables. Y is a function of independent variables. Independent variables. Y is the function of independent variables. Y, it is a function of independent variables. So in these, x1, x2 and so on, xn are the variables. So now we are going to write f is equal to x1, x2, x3 and so on, xn. So like that, its exponential form is y is equal to pi x1 to the power of a, x2 to the power of b, x3 to the power of c. So like that, x to the power of n into z. So like that, we are understanding this. This method gives best for variables 4 to 5 or 3 or 5 or 4 to 5. So then only this function gives the better relationship in dimensional analysis. More than 5 or more than 5 or more than 4 variables are existing in any function, it is this Rayleigh's method is not suitable. So whenever the less variables are there in any function, the exponential form using this dimensionless method, that is Rayleigh's method, is helpful and it is good for getting the better form. Coming to the this is the Rayleigh's method and this is the procedure. So which procedure we are using this form? So first we have to write, coming to this Rayleigh's method, the first step what we have to do is we are going to write the based on the given variables. Based on the variables, we are write the variables in dimensional, write variables dimension forms. Variables dimension forms. These dimensional quantities. So we are going to write those dimensional quantities. So so like that, for example, velocity is there. So distance by area L t to the power of minus 1 is the dimensional quantity of velocity. Coming to the area, L square is the dimensional quantity. Like that, we are writing the dimensional quantity of that particular variable. We are writing the dimensional, that is the first step. The next step is write the same equation in exponential form. So first we are writing the exponential form. Next, select suitable system of fundamental dimensions. So based on that MLT. So which type of system we are using, that is we are implementing here. Substitute dimensions of the physical quantities. So we are substituting the dimensions of the physical quantities. Apply dimensional homogeneity, equate the powers and compute the values of the exponents. Substitute the values of the exponents. So simplify the expression. Ideal of 3 independent variables can be used for 4. So this is the procedure we are following for the Rayleigh's method. So this is the one of the method. Next, move on to this Buckingham's pi theorem. So it is more generalized method of dimensional analysis developed by Buckingham's and others, and it is most popular now. So this is named after E. Buckingham's and others. They are going to develop, and it is very, very popular. This arranges the variables into a lesser number of dimensional groups of variables. Because of the Buckingham's pi theorem to represent the product of variables in each groups, we call this method is Buckingham's pi theorem. So if n is the total number of variables, this is the statement. This is the statement of the Buckingham's pi theorem. If n is the total number of variables in a dimensional homogeneous equation containing m fundamental dimensions, then they may grouped into n minus m pi terms. N minus m pi terms. So now n number of, so for it is suitable for any number of variables which presented in that particular relationship, and we required any relationship between n number of variables. It is the best method for suitable. So that is Buckingham's pi theorem. So now the function x1, x2 and so on, x to the power of n is equal to 0, then the functional relationship will be written as pi 1, pi 2 and so on, pi n minus m is equal to 0. So the final equation obtained in the form of pi 1 is equal to f of pi 2, pi 3 and so on, pi n minus m is equal to 0. So now if it is suitable for n is greater than 4 variables, and it is not applicable if n minus m is equal to 0. So this is the Buckingham's pi theorem. So procedure, coming to the procedure, in list all physical variables, note n and m. N is equal to total number of variables. M is equal to number of fundamental dimensions. Coming to this number of fundamental dimensions, the number of fundamental dimensions. So in these we have to understand, we may have x1, x2, x3, for example x4 variables. In this only L is there, in this only M is there, in this ML is there, LT is there, like that. Based on all the variables, those 3 are contained or not. It's not required for each variable contains ML, ML and T. So that is the number of fundamental dimensions. So coming based on all variables, those MLT are present or not. That is the thing we have to understand in these fundamental dimensions. So these like that we have to understand. Simply it is like that. So now compute pi terms. So now n minus m. In most of the cases, this m belongs to 3 only. In most of the more than 90% of cases, m is equal to 3. Why? Because in all the variables which is presented in given equation, this is suitable more than 4 variables. Whenever the more than 4 variables are there, for there it required the function. So then only we are using this Buckingham's pi theorem. So anyway, in all the 4 terms, definitely we will observe MLT. In most of the cases. So that's why m is equal to 3. So in any way, not for each variable contains MLT, it's not like that. So in total variables, finally MLT is the present or not. So like that we have to understand. So now write the function form, write equation. Now method of selection of repeating variable. This is the one of the important and very here only the each one has its own understanding about the Buckingham's theorem. Anyway, based on these selecting variables, we have some conditions. Based on that conditions, who will select, anyone can follow the procedure. As per that, we will get the final function. So coming to the selection of repeating variables. Coming to the selection of repeating variables. So must have all M fundamentals. That is the first thing. M fundamental dimensions. Again, it is the same. Each for each variable, it is not necessary. All whenever we are selecting repeating variables, for example, we are selecting 4 repeating variables. It depends upon the how many are there in number of variables and number of fundamental variables. Finally, we will get the n minus m pi terms. So based on that, we are selecting the repeating variables. And those 4 in that M, L, T may in any all finally we will get MLT in all 4 variables. Not each variable it's not required for MLT. Okay, so like that is the one, and should not from a pi among themselves. It not be the pi term. So those pi 1, pi 2, pi 3, those are different. For example, x1, x2, x3, x4, x5, x6, x7 variables are there in any function. So in these n minus m is equal to 7 variables are there. So 7 minus 3, for example, all the variables having MLT. So 4 are the pi terms. Now P1, P2, pi 1, pi 2, pi 3, pi 4 terms. Now we are selecting the repeating variables in the sense like this. Have x1, x2, x3, x4, x5, x6, x7 terms. So 4 pi terms. Now repeating variables we have to select, for example, x2, x3, x4, for example, 4 terms now. So repeating everywhere x2, x3, x4, x2, x3, x4, x2, x3. Those are there remaining x1 to the power of some x, whatever it, x5, x6, x7, like that we have to write. This is A1, B1, C1. No, not like that. A1. Like that we have to write. This is comes under at the time of this. So like that we have to write. So based on this, A1, B1, C1. This is dimensionless. Next A2, B2, C2. This is A3, B3, C3, A4, B4, C4. So these all the pi terms are dimensionless number. All the pi terms are dimensionless number. We are converted into m. Write the variables MLT converted into m. We are getting some equations like that. So equating into 0, we will get these exponential values. And again we resubstitute, we will get the one we will solve, and we will unknown exponents we will get after solution. So finally we will get the function form. So like this is the Buckingham's method. This is the procedure we are going to follow. These are the 2 methods we are follow for understanding the dimensional analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.